Hey everybody, it's Mr. Woodward. In this video, I'm going to show you how to use the Vernier video analysis app to track the motion of an object. So it's a web app, so you got to go to videoanalysis.app. This is, of course, assuming that you've already taken the video on your cell phone and that you're ready to import it. So I'm going to choose the file from my computer. I took the video from my iPhone and it's called Rolling Ball, and I'm going to import it here, and I instantly get this warning message that says this video is in high efficiency format and cannot be viewed. So I need to go back and change the format of that video. So I'm going to find it in the folder where I saved it. I'm going to open up that video here, and I'm going to change the format this way. In QuickTime, I'm going to export it as a new type. So I'm just going to choose 1080p, which is the resolution. But more importantly, I'm going to, down here, change the compatibility from this high efficiency format to this greater compatibility format. That's what Vernier video analysis likes. It likes this greater compatibility. So I'm going to save that. And I'm going to call it Rolling Ball New. And it's going to export it. And once that's done, I'm going to try to go back and import the video again, choosing the new file. I'm going to open up Rolling Ball New, and hopefully, sweet, it liked it. It's going to import the file, and here's the video. So if I hit play, there's this very short video of me rolling a ball across the table in my classroom. So first, I want to do this. I want to go to the beginning of the video, and I want to kind of cue it up. I want to advance. This advances the video forward 1 frame at a time, and I want to start it like right after the ball leaves my hand. So like right there is where I want to start it. And I want to set up the origin and the scale. So I'm going to click System, and first, I need to tell the video like how big stuff is. So I have a meter stick in my shot. So I'm going to take these scale markers and I'm going to drag them across the two ends of the meter stick. And notice that as I drag it, it's recording how many pixels are from here to here. So if I put this one over to the other side of the meter stick, now the software is saying that 1,228 pixels, which is the amount of pixels from here to here, is equal to 1 meter in real life, right? And let's say I wasn't using this meter stick. Let's say I knew that the entire table was like 5 feet long. Then I would just say, I would, drag this across the entire table, and I would say, and I, would need to like move some stuff around here. However I do that, say I'd measured like the entire table, and this is not the best example because the table is going off screen, but let's just say, I would say, okay, well now 1,744 pixels is equal to 5, and I would just say feet, right? Okay. But for the purposes of this video, I'm using this meter stick as my known distance. So from here to there is 1 meter, okay? All right, next, I need to set the origin, meaning the starting point of my motion. So I'm going to click origin over here, and it gives me this origin marker, and I want to put that on my ball where I want the 0 position mark to be. So I'm going to be tracking like the front edge of the ball. So I'm going to put it right there on the front edge of the ball. Okay, that's my 0, 0 mark, 0 position. Now I'm ready to start adding points. So I'm going to come over here, click add, and this is going to place a dot at the position of the ball. And it automatically advances the video forward by 1 frame. And so I'm just going to track the front edge of the ball all the way down the table. And notice that as I do that, the graph over here is like automatically populating, which is pretty sweet. So I've got, 1, 2, 3, 4, 5 points here, and it's automatically graphing it over here for me. Let's keep adding some points. Got one here, here. I'm going to track the ball all the way down And then eventually as I get to the end, and I can, you know, do this for as much data as I need. Let's just go with a lot of data. And I can continue that all the way down the table. So then I'm here, right? And I've got the data table down here, which tells me the amount of time. I can scroll through this. So starting at 0 seconds, and then here, one frame is actually about 0.035 seconds. And so it's recording the time between frames here. It's giving me the X position, which is the horizontal position, and the Y position. All the Y positions are approximately 0 because the ball is not going up or down. It's just staying horizontal. So here's my data set. It'll even give me the velocity in the horizontal direction and the vertical direction. And then it gives me this graph, okay? So what I want to do now is I want to focus on this graph. So I'm going to change my view and say, okay, get rid of the video, get rid of the data table, just focus on the graph. So a two graph view, I could graph multiple things at the same time. I'm just going to go with one graph. And then I want to, I have this red set of dots, which represents the X position, like the ball's horizontal position as it goes across the table. The blue set of dots over here is the ball's Y position, its vertical position, like its height along the table. Well, again, the heights are like roughly 0 the whole time, right? So those aren't very useful. So I'm going to get rid of those. I'm going to click this axis and switch off the Ys. I don't care about those, okay? Now I've got nicely the ball's horizontal position each frame of the video, and notice that it's a pretty straight line, okay? This has time on the x-axis, and this is position in meters on the y-axis. Okay, lastly, let's add a best fit curve, best fit line. Sometimes it's called trend line. Here it's called a curve. And this is going to apply various curve fits along many mathematical models, but I know that this is going to be a straight line, so I'm going to go with linear. Linear means straight line. I'm going to click apply. Not only is it going to add this red line, but it's also going to give me the equation of the line. So it labels it linear, and it tells me that the form is y equals mx plus b, where m, the slope, is 1.299. B, the y-intercept, is 0.02166, approximately equal to 0, right? Because this is intercepting the y-axis pretty much right at 0. And then R over here is a way of describing how well this data fits a straight line. An R value of 1 would be a perfect fit. Notice that this is 0.9998, so it's almost a perfect fit. And then another way of describing the fit is this RMSE, which is called root mean square error. An error of 0 would be a perfect fit, and notice that this is approximately equal to 0. So two ways of saying that this is a pretty darn good fit for this data set. Okay, and then I can like click through the different points, and it'll actually tell me the exact values along the line. If I want to get rid of that, I can X out. Okay, and then often from here, I will ask you to like take a screenshot. So in my particular computer, I can screenshot like this and just drag across the graph and capture it, making sure I'm getting both axes, and take a shot from there. There you go. That's an intro to Vernier video analysis. And of course, if I wanted to go back, I could just pull back the video. I could pull back the data table and all that good stuff. All right, hope this helps.